Welcome back, statistics scholars. We've finally gotten here. We have finally gotten to how to ask and answer cool research questions, or inference, where we're going to learn our one of our last conceptual pieces that we'll need in order to calculate inferential statistics that allow us to ask and answer those cool research questions like, does age impact cognitive functioning, or do men and women have different amounts of aggression? Does a new drug for depression work better than an old drug? Right, we have all these kind of research questions that we want to ask and that data analysis is for. And so we're going to learn one of our last conceptual tools in order to be able to ask and answer these research questions. And what we're going to be talking about today is something called null hypothesis significance testing. And we're going to break that down one at a time. Break down those words one at a time and learn about this broad approach to how to conduct research. And any research that has to do with people, whether it's business stats, whether it's biological statistics, whether it's medicine, anthropology, sociology, psychology, if you're dealing with people and you're dealing with data analysis and you're dealing with samples and populations, you're going to be doing a null hypothesis significance testing approach. It's the dominant approach in data analysis. It's not going anywhere anytime soon. And so this is sort of where the rubber meets the road in a class like this. Everything up to this point has sort of been the groundwork, the foundational work we needed to do. And now we're actually going to learn how to analyze data. Yay! In order to be able to ask and answer interesting research questions. So on to null hypothesis significance testing. So what is null hypothesis significance testing? Well, it's the idea that anytime a researcher has a research question, you're going to create a pair of hypotheses. You're actually going to create two hypotheses, one of which that you as the researcher thinks is really going on, and then you're going to create the opposite of that and call that the null hypothesis. And then you're going to pit these hypotheses against each other. So let me give you an example. Let's use that example that I've used several times. Do men and women have different amounts of aggression? Now, as a researcher, I'm always looking for things to be different. As researchers are looking to see that their new drugs change the symptoms of disease. If I'm interested in gender, I'm going to be interested in finding out that there are gender effects. If I'm interested to see if a brand new government program improves reading outcomes, I'm going to be looking for there to be what are called effects. I'm looking to see that groups are different. I'm looking to see that there are interesting, cool things happening in the world. And that's always what I'm going to be think is going on as the researcher. As the researcher, I think groups are different, averages are going to be different. The people's disease severity before they take the drug is going to be different than their disease severity afterwards. The bottom line is, as researchers, we're always looking for interesting effects. So it's always going to be about looking for averages that are different from one another. And that becomes our research hypothesis. But in order to do the null hypothesis significance testing approach, you create the opposite hypothesis and call that the null. And you pit what you really think is going on, your research hypothesis, against this thing that you call the null hypothesis. And you're actually going to pit these two hypotheses against each other. Now, and what you're actually going to test is what's called the null hypothesis. You're actually going to test the opposite of what you think is going on. And so your research hypothesis becomes the alternative, your awesome alternative to that boring null hypothesis that you're hoping to get rid of. But the bottom line is, whenever you ask any research question, you create two hypotheses. One hypothesis that you think is really going on, you sort of start there, like, do I think men and women have different amounts of aggression? Why, yes, I do, as the researcher. That's why I'm bothering to do this study. Right? That becomes one hypothesis, and then you create the opposite of that, where you say men and women aren't different at all, and that's boring. The idea that there are no effects in the world is boring. But we're going to test that idea. We're going to test what's called the null hypothesis, and then our research hypothesis, what we think is really going on, becomes our awesome alternative. And then we pit the null and alternative hypotheses against each other. And it's this basic idea that we're going to spend the rest of this video lecture exploring. This idea of whenever you create a research question, you're going to actually create two competing hypotheses that are the opposite of each other. What you really think is going on, which is called the alternative, which is sort of counterintuitive, but that's how it works. Your research alternative hypothesis, your awesome alternative to this other hypothesis that you create called the null. And they always are the opposite of each other. And so let's explore that idea again. Right? A researcher comes up with some awesome research question. And what they actually think is going on in the world is that groups are different. Averages are different. There are interesting findings out there in the world, like men and women are different, or kids who get Head Start have a different average academic performance than kids who don't get Head Start, that older folks have lower cognitive functioning than younger folks. Whatever, researchers are looking for there to be interesting average differences between groups. That is almost always the case. And it's certainly going to be the case in this class. So the research hypothesis becomes what we call the alternative. Research hypothesis is the alternative hypothesis. It's just the language that gets used. And I like to think of it as you start with what you really think is going on, and that's your research hypothesis. But then you're going to create this second hypothesis, which is sort of the boring opposite of what you think is really going on. So if my research hypothesis is that men and women have different amounts of aggression, then my boring null hypothesis is that they have the same amount of aggression. And then I'm going to test that null hypothesis. I'm actually going to start with the idea that there are no differences. And I'm actually going to assume that the null hypothesis is true then. I'm going to start with the assumption that the null hypothesis is true, start out with the assumption that the opposite of what I really think is going on is true. If I think men and women are different in terms of aggression, I'm going to create the opposite hypothesis. I'm going to call it the null. And I'm actually going to start with the assumption that the null hypothesis is true and then hope to get rid of it. So null is actually French for lame, which is how I remember it. I go, no, the groups are not different. The groups are not at all different from each other. There are no interesting effects in the world. Men and women are exactly the same. Nothing to see. Null findings. Drive through. Nothing to see. And so because I'm testing that idea, I'm testing the null hypothesis, hoping to reject it, because I am. I'm hoping to get rid of that null hypothesis, because if it's really the opposite of what I think is really going on, then that's going to provide evidence for my research hypothesis, which then becomes the alternative, but it's the alternative to that boring null. So I start out with a research hypothesis. Do men and women have different amounts of aggression? Because I think they do, right? Let's just talk about physical aggression, because there's actually good research to suggest men are more physically aggressive than women. That's not true when you broaden your definition of aggression, but let's just leave it at that, right? I, as a researcher, want to demonstrate that men and women have different amounts of aggression. That's what I think is going on. So that's my research hypothesis. But then I create my null hypothesis as a comparison. I create this null, boring comparison hypothesis where I say that the groups are not different, that men and women are exactly the same, that they are not different, and that is the hypothesis I'm going to test. I'm going to test the null hypothesis, the boring hypothesis, the comparison hypothesis. And so because that is the hypothesis I'm actually going to test, that boring idea that the groups are not different, that men and women are not different, then my research hypothesis becomes the alternative to that boring universe where men and women were not different, right? And this approach can be used for any research question, as long as you're looking at averages. And the null hypothesis significance approach is most often used with averages. but it can be used for other things as well. But that's the idea. Start out with a research question where you think there are some differences out there in the world. Groups are different, and that's what researchers are usually hoping to find. That new drugs work better. See how that's different? New drugs work better than old drugs. That new programs to help kids improve those scores, right? There are differences, and we're going to be tracking averages to look to see if there are differences. And so researchers are looking to see if the averages are different for some research question. So we create a null hypothesis where we say they're not different, that the groups are exactly the same. So that becomes our comparison, right? Our comparison hypothesis, which then turns our research hypothesis into the alternative. And then if we can reject the null, if we reject the idea that men and women aren't different, well, that means they must be different, right? There must be some difference in the average amounts of aggression for men and women. And so we're going to pit the null and alternative hypothesis against each other by creating these pairs of hypotheses called null and alternative hypotheses, where the alternative is what you really think is going on. And then you pit the null and alternative hypotheses against each other, where you actually test the null. And if you can get rid of the null, then that provides evidence for the alternative. If I can get rid of the idea that men and women are the same, well, then I guess the men and women must be different in terms of aggression, if that's what I'm looking at, if I'm looking at average aggression. All right, so how do we do this? What is the nitty-gritty? Well, first and foremost, researchers are always hoping to reject the null hypothesis. That at least usually, 99.9% of the time. In more advanced statistics, that story is a little bit different, but certainly for introduction to statistics, a foundational statistics class, we as researchers are always hoping to reject the null boring hypothesis, this comparison hypothesis that I've simply created so that I can test what I really think is going on, right? We want to reject the null, because if we can reject the null, then we can go with all our awesome alternative or our research hypothesis. This is what we want to do. We're going to test the null in the hopes to reject it. It's a very strange way of thinking about the world, but I'm not making it up, I promise. This is in fact what we do. It's kind of like I say to you, if it's not black, it must be white. So I'm going to reject the idea that it's black, because if I can reject that idea, then it must be white. It's that same basic idea. Either the null is true or my awesome alternative research hypothesis is true. So I'm going to use the null as my comparison. And I'm going to throw out the null so that leaves me with my alternative. Or like you're flipping a coin. Null is on the one side, alternative is on the other. And if you can reject the null, then it must have come up alternative, right? And then we're going to test the null and hope to get rid of it. Now, but that doesn't always happen. We don't always get to reject the null hypothesis, right? Sometimes we keep the null hypothesis. We retain it, right? We keep that null hypothesis around. We call this failing to reject, because it is a failure. You are super bummed out as a researcher if you don't get to reject the null. Because remember, the null is that lame thing. If I'm a gender researcher and I really think men and women show different amounts of average physical aggression, I'm hoping to find average differences. But the null says that men and women won't be different. And if I fail to reject that idea, if I keep that idea around that men and women are the same, well, then I'm bummed out, because then, well, what I was hoping to find as a researcher wasn't supported. I failed to reject the null. I retain the null. Now, we don't say we prove the null, and that's important. And as we go through our discussion, I'll try to point out to you why we don't use that kind of phrasing. We either reject the null and we do a happy dance, because that means our research hypothesis was supported. The groups were different, right? Averages were different. There were cool effects in the world. Or we fail to reject. We retain the null. We don't prove it. We just keep it around. We fail to reject it. We don't have good evidence for our research alternative hypothesis, which makes us bummed out as researchers, right? Because we wanted to go with our awesome alternative hypothesis where we said that groups were different. And this is a very funky way of thinking about the world, right? Why don't we just only focus on the research hypothesis? Why do we have to create this null hypothesis? Why do we have to create these competing hypotheses? That's weird. Well, and the reason that we do it this way is because we create the null as this stable comparison, right? We're going to collect some data, and we're hoping that our data supports our research hypothesis. We're hoping that after we collect data, our awesome alternative research hypothesis is supported. And if to use my example about men and women and aggression, I'm hoping that I gather data that makes it really clear that men and women have very different amounts of physical aggression. But I need to, when I collect that data, compare it to something. Compare it to something stable. Compare it to something predictable. And so I create this null hypothesis as a comparison. And then I sort of check my data against my null and hope to get rid of the null hypothesis so that I can confidently say, yes, I've rejected this boring null hypothesis that my groups were not different. So I can confidently say, yes, my groups were different. I was able to reject the idea, reject the hypothesis that my groups were the same, that men and women had the exact same amounts of aggression. And because I rejected that idea, I rejected that hypothesis, I'm left with, well, I guess my groups are different. Men and women have different amounts of aggression. And our whole discussion as a part of this lecture is learning how to do null hypothesis significance testing. But before I taught you how to do it, we needed to sort of understand why we take this approach and sort of to understand the basic idea. And so right now, I want you to make sure, take a minute, maybe even pause the video, and make sure you understand the approach, the general approach. Come up with some research hypothesis where you say that group averages will be different. This group is going to be different from this group because you're going to test some cool effect, some effect of gender on aggression. Create a null hypothesis that is the opposite of that, where you're saying the world is boring and lame, where these groups are not different. Test the idea that the groups are not different and hope to reject that idea. Reject that hypothesis that men and women are not different. And if you can reject it, that gives you evidence for your awesome alternative research hypothesis. So just as a vocab check, another vocab check to make sure we're on the same page. Your research hypothesis is the awesome alternative. What is it an alternative to? The boring, lame, null hypothesis, which is just created as a comparison so that you can hopefully reject it. And if this is confusing at all, now is the time to shoot me an email or shoot me a question in the Q&A forum to make sure you have this basic foundational concept really solidified and firm before you move on. All right? So let's move on. So, null and alternative hypotheses must always be created in pairs. So every time you ask a research question, literally every single time you ask a research question, there's going to be a null hypothesis, which is boring, that will say group averages are equal. This group is going to be equal to this other group. So a null hypothesis will always have a mathematical equality, like an equal sign. It will say this average is equal to some specific number, right? The alternative, your awesome alternative, which is also your research hypothesis, what you think is really going on, will always have an inequality. Researchers will always, at least if they're using this approach, will be saying that their averages are unequal to something. And so averages will have an inequality, that some average will be not equal to some specific value. And when you create these null and alternative hypotheses, think of these as events from our discussion about probability. Oh, you have to remember back to probability? Yep, got to remember back to that probability lecture. And if you remember, an event is an outcome. So think about your research, if you're a researcher, as you're going to do a trial. And there's two competing events. One event is that the null is true, that your averages are going to be equal to some value, some boring value. your alternative research hypothesis is going to be not equal to some value, as an example. And so when taken together, these two events are mutually exclusive. If the average is equal to some number, then that mutually excludes that it's not equal to some number, right? And collectively exhaustive, meaning there are no other options. Equal to or not equal to, I can't think of any other options, right? And so let's come up with a specific research question to make sure you understand this idea. I want to know if in New York, because let's say I'm reading a magazine, and I actually did read a newspaper article about this about a year ago. I'm interested to see if the families in New York City, like living on Manhattan, have like a different average number of children than like the U.S. in general. I was reading this article, and they suggested that the people in Manhattan have different amounts of kids, right, than sort of the U.S. population in general. And I happen to know that the average number of children across the U.S. is 2.17. So what I'm really asking as a researcher is, in New York City, is the average number of children, is the mu there? Remember, mu is just the population average. I'm wondering if the average in New York City is different than the number of children in the U.S. in general. So now I can create my null and alternative hypothesis. Now I'm curious to see if those in New York City are different. If I didn't think being in New York City had any effect at all on how many kids you have, I wouldn't be bothered to do this research, because my research hypothesis is always that I think that there's some effect in the world, some effect of living in New York City on the average number of kids that you have, right? So my research question is, do the families in New York City have a different average number of children than the U.S. in general, where I happen to know the average in the U.S. in general is 2.17. So I could say in my null hypothesis, which is our comparison hypothesis, it's that boring hypothesis that I create as a comparison. I say, well, according to the null, the boring hypothesis, in New York City, the average number of children in a family is equal to 2.17. So it's exactly equal to the U.S. population in general. So the U.S. population becomes my comparison population, and the null hypothesis becomes my comparison hypothesis, where I say, nope, people in New York City, no different than the U.S. in general. So in New York City, the average number of children is equal to 2.17 also. But my alternative hypothesis is just my research hypothesis, right? In New York City, the average number of children is not equal to 2.17. There is some interesting effect of living in New York City on the number of children that you have. It's not going to be 2.17. It's going to be something else. And these are the two hypotheses I pit against each other. And notice that these two possible outcomes, equal to 2.17, not equal to 2.17, they're mutually exclusive. Either in New York City, the average number of kids is also 2.17, or it's not 2.17, mutually exclusive. If one is true, the other can't be true. Also collectively exhaustive. There are no other options, equal to, not equal to. And because you create your null and alternative hypotheses this way, because if one is true, the other has to be false, and vice versa, if you can reject the null hypothesis, if you reject in New York City the average number of children is 2.17, if you get rid of that idea, what are you left with? Well, I guess it must be true that it's not equal to 2.17, right? Because when you create your competing sets of events this way, when you create your null and alternative hypotheses pairs this way, rejecting the null, in fact, leaves you with your awesome research alternative hypothesis that you were hoping to find support for. So it's really important to keep these ideas in mind. So let's go back to this research example, because not all null and alternative hypotheses pairs are created equal, right? So we go back to this question. In New York City, is the average number of children in a family different than 2.17? That's my research hypothesis. There are really a lot of competing possibilities, right? They could be the two possibilities that I presented you with initially. Are the means equal? Are the means not equal, right? Are the means equal? Are they not equal? But I could want to be more specific than that, right? What if I want to get more specific? What if I want to say, I want to go beyond just they're not equal? What if I want to test a much more specific idea that like those in New York City have more children, greater amounts of children than the US in general? Or what if I want to test the idea that those in New York City have fewer children? The average is going to be less than the US in general. Well, these are things you can do in a null hypothesis approach. And this is the idea of what's called directionality. Sometimes, and much more often than not, researchers will ask what's called a non-directional set of hypotheses, where you're simply exploring to see if the groups are different, but you're not specifying how they're different, right? So, and this is the kind of examples that I've been giving you so far, right? Where I say, is the number of kids in New York simply different than the US in general? It's called a non-directional approach because you're not saying which it's going to be ahead of time. When you walk into your research study, you're not specifying that the people in New York City are going to have more kids than average. You're not specifying that they're going to have less kids than average. You're simply exploring the idea that they're going to be different. So this is called non-directional because you're not looking in the direction of higher or in the direction of lower. You're just saying they're going to be different, right? This is called the direction of the effect. You don't hypothesize ahead of time which way it's going to turn out, right? Once you see the results, you'll know, but you're not going to hypothesize ahead of time which way it's going to be. This is also called a two-tailed test, which I just want you to file in the back of your brain, and I'll talk about a little later on in the lecture why we call it a two-tailed test. But sometimes researchers have a very specific agenda where they are only looking for their findings to be in what's called a particular direction. And let me give you we call this, again, the direction of the effect. Where let's say I'm a researcher and I'm interested in a very rapidly changing trend in New York City, where I start noticing anecdotally, I start seeing families, very wealthy families, having 5, 6, 7, a whole lot of kids. And I start interviewing these families, and they're telling me that having lots of kids is sort of like a status symbol because they can afford a large house in Manhattan to house all those children. They can afford the private school costs of 5 children. And so I'm very interested to see only if the number of children in New York City is higher than average. I'm not interested in discovering that they're lower than average. I'm specifying the direction of the effect. I'm specifying that I only am interested in discovering that the people in New York City, the families in New York City, have greater numbers of children than average. Or that would be an example of a one-tailed test, a directional test, where I'm not just saying that I think that my research hypothesis is going to be that the families in New York City are different. I'm saying that the families in New York City are specifically going to have greater numbers of children than the US has on average. Or I could do a different directional hypothesis. I could be worried about a different effect in New York City. Let's say I'm concerned that birth rates are falling in New York City. Let's say I think that there's some contaminant in the water, and I think that birth rates are falling there, and because of this contaminant. And I'm only interested in exploring if people in New York City, families in New York City, are having fewer children than average. If they're having more kids than average, I don't care. I'm completely uninterested in finding that. I'm only interested in exploring the idea in terms of my research hypothesis, my awesome alternative research hypothesis. I'm only interested in discovering that people in New York City are having fewer kids than average and demonstrating that so I can, sound the alarm. That would be another example of a directional hypothesis, where I'm specifying the direction of my research hypothesis effect. I'm only going to be interested if The people in New York City have fewer children than average. And so these are the two, this is a question you have to ask yourself as a researcher. Am I doing a non-directional test? Am I going to create non-directional hypotheses? Or I'm simply going to ask the question, are the groups different? We call this a two-tailed test because you're looking up there and down there. You're looking sort of for the averages to be above average. You're looking for averages to be below, right? You're looking in all the different directions, in all the possible tails. But a directional hypothesis, you're specifying. I'm only going to look in one direction. I'm not going to look in the other direction. A one-directional test, a directional set of hypotheses. And then you have to pick. Are you going to check to see if it's greater than? Or are you going to check to see if it's less than? Because you're only allowed to look in one direction. And let's go over some examples of this to really wrap our head around the idea of directionality. And again, it's a question you have to ask yourself as the researcher before you collect a single data point. Before you collect data on a single family, you have to decide, what do I care about? Do I care about simply finding out that people in New York City are different? Because I might, right? It might be really fascinating for me to discover that they're having more kids than average, and equally fascinating for me to discover that they're having less kids than average. Both of those things might be interesting to me, and so I would do a non-directional set of hypotheses. I would create a null and alternative hypothesis that are non-directional. But I might say, no, I'm only interested in discovering that they're having fewer kids than average because I'm concerned about the water supply, directional effect. Or I'm maybe only interested to see that they're having a lot more kids than average because I'm sort of fascinated by the idea of them having a bunch of kids as a status symbol. For having fewer kids than average, that doesn't interest me. But you have to decide as a researcher. And how do you decide? That's up to you. You decide what questions interest you. Do non-directional hypotheses interest you? Let's look for effects in either direction. Or do only a directional set of hypotheses interest you? Then you would do a one-tailed or a directional test. So let's look at some formalities now, right? So my research question is, in New York City, is the average number of children in a family different than 2.17? What's 2.17? It's the known general population, right, over the U.S., based on like the U.S. Census data of the average number of kids. So in all 50 states, the average number of kids is 2.17, right? And I'm curious if people in New York City are different from that. And if I am very curious, if I would be fascinated and interested to discover that people in New York City are having a whole lot more kids than average, and I would be equally interested in finding out that they would be having far less kids than average, well, then I'm going to create my non-directional set of hypotheses, where the null or comparison hypothesis is that in New York City, they have the same number of children as the U.S. in general. So the average in New York City is equal to 2.17. The average in New York City is equal to 2.17. Where the research hypothesis, the alternative hypothesis, what I really think is going on is that in New York City, the average number of children is not equal to 2.17, right? And so now I have to teach you the formal symbols. Here are the formal symbols down here that I've boxed for you in red, right? If you're doing a non-directional set of hypotheses, we call the fact that it's a hypothesis H. That's the symbol for hypothesis. And so the alternative hypothesis gets labeled H sub 1. So the alternative hypothesis is that the average, mu, in New York City, right? The average mu in New York City is not equal to 2.17. That is the awesome alternative hypothesis. What you really think is going on, that in New York City, the mu for the average number of children is something different than 2.17. That there's something interesting and cool about New York City in terms of research, because I'm always because researchers are always interested in finding interesting effects. Wow, let me go on Oprah and talk about how in New York City people are having different number of kids than average. Isn't that fascinating, right? So my alternative hypothesis, H sub 1, is that the mu in New York City is not equal to 2.17. It's something different. Where the null hypothesis is symbolized as H sub 0. That's right here. H sub 0 stands for zero, boring, right? That nothing to see, right? And that hypothesis is the comparison, right? It's the comparison hypothesis where you say that the mu in New York City, the average number of children in New York City, is just equal to 2.17. Nothing to see, nothing special about New York. New York is absolutely no different than the rest of the country. And this would be an example of a null and alternative hypothesis pair that are mutually exclusive. If one happens, the other cannot. Collectively exhaustive, there's no other options. And if you can reject the null, reject the idea that the average in New York City, mu in New York City, remember mu, just that Greek letter, that the mu in New York City is equal to 2.17. If you can reject that, well, then you get to go with the alternative, your research hypothesis. And you do a happy dance and you go on Oprah talking about the weird folks in New York City who are having different numbers of children than average, right? Either they're having more kids than average or they're having less kids than average. Your research will discover that, but you would be fascinated to discover either of those things. But let's then explore directional hypotheses. Because let's say this is the idea. Let's say you as a researcher are interested because you think people in New York, on Manhattan, are having more kids than average. You suspect this because you've been talking to some really rich people there anecdotally, right? And they're talking about having 5, 6, 7 kids, and you're like, that would be a super interesting idea to discover. And so you're chasing that idea as a researcher. And so when you have an alternative research hypothesis now, you're specifying that in New York City, the average number of children in a family is greater than 2.17. And because your actual research hypothesis specifies that you're only interested in discovering that people in New York City are having more kids than average, and you can decide if that's all you're interested in, you're the researcher. Then you have to create a null hypothesis that is the opposite of that is the mutually exclusive, collectively exhaustive opposite of that. And so then your null hypothesis becomes that the average number of kids in New York City is either equal to or less than 2.17. Equal to or less than? Yeah, because then that would be mutually exclusive and collectively exhaustive. If it is true that in the New York City, it's greater than, well, then it can't be less than or equal to. And if it's true that it's either less than or equal to, then it can't be true that it's greater, right? And so, but the null hypothesis is sort of treating being equal to or less than as the exact same outcome. It's like, well, less than, equal to, that means the same thing. Because if I find out they're having a whole lot less kids than average, I don't care. I don't care as the researcher. Finding out that they're having a whole lot less kids than average is boring to me. So it's a part of the null hypothesis. It's a part of that equal to. So your research hypothesis, your awesome alternative research hypothesis, is that the people in New York City are having greater amounts of kids than average, greater than 2.17. And so then the boring comparison hypothesis, the boring null hypothesis, is that they're having equal to or less than. Where equal to or less than are like the same thing, just not greater than, right? It's like you're saying they're either going to be greater than or not greater than. And not greater than would be either equal to or less than. And here are the formal symbols. The symbol for the alternative is still H sub 1, and we still have mu for New York City, but now we have specifying greater than 2.17, where the null hypothesis must then be H sub 0, that doesn't change. So the mu of New York City is less than or equal to 2.17. So you're creating this comparison that is mutually exclusive. If it's greater than, it can't be equal to or less than. That can't be both be true. But also collectively exhaustive, right? And notice something also, that when we had our non-directional hypothesis, the alternative always had an inequality, saying not equal to. The null hypothesis always had an equality, an equal sign. And that's true as well here. This is an example of an inequality. You're just specifying. Yep, they're definitely not going to be equal. In fact, I'm only interested in finding out that they're not equal in the greater than direction. Where the null hypothesis is still saying that they're going to be equal. They're just going to be equal to or less than. But less than is like the same thing as being equal because you don't care about finding out that the people in New York City are having less kids than average. And again, you as the researcher get to decide what you're interested in. You would only create a null hypothesis where you're saying they're either less than or equal to. You would only create that sort of comparison null hypothesis if you literally only cared to find that the people in New York City were having more kids than average. You get to decide. Most psychologists do non-directional tests. In fact, most researchers who do null hypothesis significance testing, most people do non-directional tests. But there are some disciplines, like in medicine. Medicine is a discipline where sometimes they'll do directional effects, right? Where they would be only interested in discovering if a drug improves symptoms. Right? Here that improves, you're only looking for the new drug, let's say, to make the average disease severity better. If you find out that the drug makes it worse, that's like the same as it not working at all, right? And so in some disciplines, there are directional effects. But in psychology, sociology, sort of the behavioral sciences, really we do non-directional hypotheses most of the time. But it's important as a good, well-rounded education in statistics for you to know about both. So we've got non-directional effects, non-directional tests, where we just say equal to in the null, not equal to in the alternative, where the alternative is what you're hoping to support by rejecting the null. And then we have one possible directional set of hypotheses where you're specifying that people in New York City have greater numbers of children than average as your alternative research hypothesis. So you go ahead and test the idea that they either have less than or equal to, hoping to reject it. But another potential directional hypothesis, set of directional hypotheses that I could come up with. Because what about that researcher who is only interested in discovering that people in New York City have less kids than average because she's concerned about the water supply, right? So if she's completely uninterested in finding out that people in New York City have more kids than average. If they have more kids than average, who cares? That's the same thing to her as if they're having the same number of children, right? And so she has a research hypothesis that specifies in New York City, the number of children in a family is less than 2.17 because that's her concern. Her research concern is that there is some drop in fertility in New York City. And so that is her awesome research hypothesis, her awesome alternative. So she's going to create a comparison hypothesis, a null hypothesis, where the number of children in New York City is equal to or greater than. Equal to or greater than. Equal to or greater than is the same as being equal to because I don't care about it as a researcher right now. And once again, here are the formal symbols boxed in red. The awesome alternative, what you really think is going on, and it wouldn't be an awesome outcome, but as a researcher, this is what you're looking to find. She's looking to establish evidence that the average in New York City, mu for New York City, is less than 2.17 so that she can raise the alarm and bring people's attention to this possible problem of fertility in New York City. So she creates this comparison null hypothesis, H sub 0, where the average mu in New York City is greater than or equal to 2.17. That is her comparison. And it becomes her comparison null hypothesis because of what she was originally interested in. What she was originally interested in was that the average is going to be less than 2.17, the known population average across the US. And you can use this approach for any research question. You can drop any research question into this sort of model and test it, which makes this a really powerful approach. So, just to sum up, if we're thinking about a null hypothesis, here's some rules that you just need to memorize. And they're going to be helpful and for you to sort of recognizing null and alternative hypotheses when you see them. A null hypothesis is always going to state that some parameter that you care about, parameter, like a mu, is always going to state that a parameter, like an average, like mu, is going to be equal to some value, right? There's always going to be the word equal in there, right? If it doesn't have the word equal in there, then it's not a null hypothesis. If you reject the null hypothesis, this gives you evidence for the alternative, the research hypothesis, which is what you're looking to find as the researcher, what you're looking to find evidence for. This is what you want to do. You want to reject the null hypothesis as a researcher. And here are some possible formal notations for null hypotheses. If you're doing a non-directional test, this is what the formal symbols are going to be for a null hypothesis. Mu will be equal to some number, right? Now, if you're doing a directional set of hypothesis, you could be stating as the comparison that the mu is less than or equal to. If you're doing a different kind of directional hypothesis, you could be saying in your null comparison that the mu is greater than or equal to some number. And so these are the only possible null hypotheses, are these formal symbols right here. There are no exceptions. And so from the example research question, in New York City, is the average number of children in a family different than 2.17? A possible null hypothesis would be that the average number of children is in fact equal to 2.17, right? It could be equal to 2.17. You could say it's equal to or less than. You could say it's equal to or greater than, but it's always going to have that word equal there. The boring idea that the groups are not different. That in New York City, that group is not different than the entire US population as a whole. There are no effects. Now, in the alternative hypothesis, to sort of sum up and give you some tips, an alternative is what you really think is going on. Why is it called the alternative? Because you test the null so that you can go with the alternative, your awesome research hypothesis, your awesome alternative. It's always going to say some parameter, like mu. It's like the average is going to be not equal to some value, right? There's always going to be some sort of language that suggests that the groups are different, that they're not equal, that people in New York City are not the same as the US population in general in terms of the number of children that people have. And again, you're hoping to reject the null hypothesis. That's what you want to do as the researcher, so you can have evidence that your alternative research hypothesis is legit. Because then you can go on Oprah and talk about your findings. Then you can publish a book and sell your book for $19.95 at the airport, right? The idea is you want to find interesting effects. Nobody's going to be interested if you say, yeah, the people in New York City, they're totally not different than anyone else. That's boring. No one is looking to find that, right? And so here again are the formal notations. Alternative hypotheses always have H1, that stands for the alternative research hypothesis. If you have a non-directional hypothesis, then the alternative is just that they're not equal, that the average mu is not equal to some specific number. And here are two then directional, right? You may specify as the researcher and say, nope, I'm only interested in discovering my average is less than some value, or you may specify it in the other way. Nope, I'm only interested in that the average is greater than some number. And you have to pick ahead of time. Are you going to do option 1, 2, or 3? Are you going to test a non-directional hypothesis? Like this one? Whoops. Are you just going to test the idea that they're either equal to or not equal to? Are you going to test this set of directional hypotheses where you're saying, people in New York City, I think they have greater numbers of children than average. So you test the null that they have less than or equal to. Or are you going to test this one? You suspect people in New York City have less kids than average. So you're going to test the null hypothesis that they have greater to or less, or greater to or equal to, greater than or equal to, right? And so you pick option 1, option 2, or option 3. Right? You got to pick as the researcher. What kind of possibilities are you going to explore? And you got to pick one. And so an alternative hypothesis is always going to have some statement that your groups are different, that the people in New York City are different in terms of the number of children that they have than the US in general, that their average is not equal to 2.17 as an example. That would be the non-directional, two-tailed alternative research hypothesis. So let's do a couple more examples, right? Make sure we really got a handle on this. Is the mean psychological well-being of men who enlist in the U.S. Army different than the average psychological well-being of U.S. men in general? Which I happen to know is mu equals 44 with a sigma of 6, right? So I know the average for the general well-being in the U.S., it's 44, and I know the standard deviation, right? This is the population average for men in general. Maybe I got this from census data. Maybe I got this from a large a series of studies that demonstrated that the average, the known average for men in general in the U.S. is mu equals 44 with a deviation, that's lowercase Greek letter sigma, is equal to 6, right? So all that should be review, right? Average is the same as the mean, and mu is just our symbol for the population mean. And I know that in general, in the United States, the average amount of sort of well-being is 44. That's the average, with a standard deviation of 6. Sigma equals 6, right? And so but then I'm curious if being in the Army is going to have some effect on that well-being. I think that being in the Army is changing men's well-being. And I would be interested in discovering that being in the Army improves well-being. And I would be equally interested in discovering that being in the Army hurts well-being. So I'm going to do a non-directional set of hypotheses. Because I suspect there's going to be some change, that being in the Army is going to change men's well-being, I create my comparison null hypothesis where I say that the average in the Army is going to be equal to men in general. So it's going to be equal to 44. Because my awesome alternative, my research hypothesis, is that it's not equal to 44, right? In general, men have a well-being, an average well-being of 44, right? And in the U.S. in general, and I suspect my research alternative hypothesis, my alternative research hypothesis, is that it's not equal to 44. And here's formal symbols, right? I suspect that being in the Army makes their well-being different, not equal to 44. So I create my comparison hypothesis where I say that the average of being in the Army, the mu of being in the Army, their well-being score will be equal to 44. And that becomes my pair of hypotheses that I pit against each other. And remember, this was a non-directional hypothesis because I just wanted to know if the two groups were going to be different. And it's called a two-tailed test because I'm looking in sort of both tails of the possible effect. One tail, two tails, because I'm looking for things to either be greater than or be less than, right? So I'll put my thumbs up either that away or that away and make myself two tails, right? Is the well-being of these two groups going to be different? But I could do a directional hypothesis. I could say, nope, I suspect being in the Army hurts men's psychological well-being. Because let's say I think there needs to be greater funding for mental health for men in the armed forces. And so I, as a researcher, am only sort of interested in exploring the idea that being in the armed forces, being in the Army, is really hurting men's psychological well-being. If I discover that it helps their well-being, well, then I'm not going to be arguing for greater funding for mental health, right? So I'm going to treat them that having a higher well-being as the same as being equal to. So I'm only going to be looking in one direction. I'm only going to be looking for being in the Army sort of hurting their psychological well-being, right? So this is called a one-tailed test because I only look in sort of one tail of the effect. I only look in one direction, right? And so that is one example of a directional hypothesis that I could do. But how I phrased it up here is I phrased it non-directionally. I was either interested in them being different or not different, right? Because I personally would be very interested to discover either of those things as a researcher. If I discovered that being in the Army was causing men to have this huge boost in well-being, I would want to know that. And I would want to tell someone and write it up and go, hey, guess what? Being in the Army is totally helping men's psychological well-being. But I would also want to be interested in discovering that it hurts their well-being. So I would just want to discover that they're not the same as the general population, that being in the Army has some effect. So I'm going to create a hypothesis that simply states that they're exactly the same. So let me give you an example with direction, right? And how I would sort of translate the research question into these sort of formal ideas. So let's say I'm a lawyer. And let's say I'm an arrogant lawyer, and I'm just super into my profession, and I just think my profession is super awesome. And I'm curious. I say to myself, I wonder if pre-law students have ACT scores that are higher than average, higher than the general population. And so I say to myself, okay, pre-law students, do they have higher ACT scores? And the ACT is like the SAT for no one who's heard of it. It's this sort of test to see if you're like prepared for college, if you're like have academic preparation. And I'm only interested in discovering that these law students have higher ACTs than average, than the general population of just kids in general, of students in general. And I happen to know that the average ACT score is 21, so mu equals 21, and they have a standard deviation of 6, right? I just sort of know that ahead of time. But my research hypothesis, because I'm only interested in discovering that these pre-law students are better than the population in general, well, then my null hypothesis has to be sort of the opposite of that. My comparison hypothesis that I create as a comparison to what I really think is going on has to be that they're lower or equal to, right? And because my awesome alternative, as the lawyer, I think that they're actually better, that they're higher. And so here becomes the formal notation. The null hypothesis, H sub 0, is that the average for law students is less than or equal to 21, because that's the opposite of what I really think is going on as this lawyer, that the mu law students is greater than 21. But notice, the null hypothesis is still saying that things are going to be equal to. They're just saying equal to or less than. Because less than is the same to or as equal to. Because as the lawyer, if I find out that pre-law students have lower ACT scores than average, I'm not even going to tell anyone. I'm just going to say, well, it was less than or equal to, and I went with that, right? I didn't reject that null hypothesis. They were less than or equal to 21. But you're not going to tell anyone that they actually were less than. You're going to treat less than and equal to as the same sort of outcome. But the alternative then is that they're higher than 21, that average ACT score for law students is higher than 21, right? This is an inequality. This is still equality. You're still saying things are equal. You're still saying things are not equal. You're just specifying. Here, you're specifying how they're not equal, that they're greater than. So your null hypothesis has to be less than or equal to. So making a decision. This is going to be our topic for our next video lecture, because what I really want you to do is I want you to sit with these ideas, really wrap your head around the vocab terms, the terminology that we went over, understand the basic ideas behind null hypothesis significance testing, before you move on to the next lecture, where we sort of ask the question, which is it going to be? Are we going to go with the null hypothesis and be sad because we're saying the groups are not different, things are boring? Or are we going to be able to go with our research hypothesis and be happy? And what we're going to discover in our next video lecture is that we're going to test the null hypothesis. It is the null hypothesis that we're going to test. We're going to test it, and we're going to start out with the assumption that the null is true. We're going to say, okay, let's start assuming that the groups are not different. Then we're going to work some probabilities. Ooh, probabilities. That's right. We're going to work some probabilities. We're going to gather a sample of people, and then we're going to try to figure out how probable our sample is. We're going to actually gather some data. We're going to figure out how probable our sample is if the null is true. And it's this sort of question that's going to allow us to decide which hypothesis to go with. Are we going to be able to reject the null hypothesis and be happy? Or are we gonna fail to reject, right? Are we gonna retain the null and be bummed out? Because if we reject the null, we get to go with the alternative, which is our research hypothesis. If we fail to reject, we found no evidence for our research hypothesis and we're super bummed out, right? So make sure all of the concepts that I've gone over in this lecture are super solid, super solidified before you move on to the next one. And in our next lecture, we'll talk about how we make this decision. See you next time.